this concept about turning line angle into chair helps you various ways on the exam. You're gonna have to do both. Know how to go from line angle to chair and chair to line angle. Um, there could be two line angles and you're comparing them to see what's the relation between them. Or there could be one line angle and one chair. In case of that, you gotta convert either of them into the same form so you can easily compare it. Sometimes he just gives you a line angle and tells you to draw a chair as a separate question as well. So this is very important. Okay, so this is the structure that we have, and we want to turn this into two conformers of line angle. If you see this chair and that chair, there is a slight difference between them. This is carbon 1, just pointing down. When you switch this, one's going to point on the top. That's the difference between these two. Okay, so let's see if carbon, this is 1, that's 2, and that's 3. Now, one thing you gotta make sure, whatever is on a dash always goes on the down position at that carbon. So this is the carbon. Let's see if we make this carbon number 1. It has two positions, up, which is equatorial, down, which is axial. Every single carbon on the chair has two positions, equatorial and axial. So make sure down, whatever's on a dash, is always on a down position. Sometimes down will be equatorial, up will be axial, which is the carbon right next to it. This is axial, that's equatorial. Alright, so it switches throughout the chair, but whatever carbon that we make carbon 1, axial is down, so we're going to put the methyl on down position. Going to erase this so you can see it better. Okay. So we have methyl on a down position right now. Now, carbon number 3 is where the Cl is. It's clockwise to methyl. So you have to go clockwise on the chair as well. So this is your carbon 3. If you go the other way, it's wrong because the other way it's 1, 2, 3, 4, and it's 4 carbon away, counterclockwise. So it's 1, 2, 3, and 4. So you would end up at the same place, but make sure you don't put your chlorine on this carbon, making it carbon number 3. Okay, now this is on a wedge, so we're gonna put it on a top. So this is the equatorial position, which is top, axial is down. So we're gonna put chlorine up. So the conformer of this, I can't use that arrow. I'm gonna use this arrow. This is the arrow for conformer. 1 is on the top now. So methyl will be equatorial because that's the down position. And this is 3. Chlorine will be axial because that is the up position. Alright, so conformers, the substituents get the exact same position. So if it's axial, it's equatorial. Equatorial, it's going to be axial. Sometimes from the substituents where they are, you can tell the stability of the chair as well. So methyl is tetrahedral. Chlorine is just like one atom that's connected there. So we want the methyl to be on equatorial for it to be more stable because it's tetrahedral, so it also has the other hydrogen which could potentially interact with other substituents that are there. So this, just because of methyl being equatorial, this looks more stable than that. So this is more stable. Conformers are exact same connectivity, exact same substituents where they are, except the position's different. So axial, equatorial is the position. Equatorial is always more stable because it's not in anyone's way. So we want our bulky groups to be on equatorial to call it a stable chair. And in that, you think about T-butyl group being on a chair. We would always want that to be on equatorial for a stable chair. Alright, so the only difference between these two conformers are the energy or the stability. Higher the energy, less stable it is. Lower the energy, more stable it is. Okay, alright, so I hope this helped. Make sure you know how to go back and forth. If you already have a chair, if it's on a down position, then you would put it on a dash. If it's up position at that carbon, you would put it on a wedge. And make sure if it goes counterclockwise or clockwise, you decide that on your chair as well. Okay, I hope this helped.
The Teaching Center, UF's Learning Resource Center.